Hi, welcome to video 6. In this video, we will learn what is a contract and need of it, introduction to interface. Using available interfaces like comparable, we want to introduce what is called as multiple inheritance. Multiple inheritance. So on the verge of it, I just want to have a simplest understanding as what we have not done. So here, I assume that there's a class. I call this, okay, so I have a class which is called as x1. I have another class which is called as x2, and I have a class which is called as x3. So where these two people will inherit the property from the superclass. That is where we want to show something called as inheritance. But unfortunately, when it comes to class, we've been following this syntax of writing it. Class uh, first extends. Second, this is what you can do. You cannot write. You cannot write. This is not allowed. This is invalid. And neither you can write. Third, this is also invalid. So hope this is making sense. So when it comes to class behavior, because first is a class, second is a class. When it comes to class behavior, you don't have any opportunity where we can have uh, you can inherit from multiple parents. This is one of the classic problems which is had from C++ to avoid diamond problem. So in order to make sure, there is another guy who comes in world who's called as interface, interfaces. So interfaces, they don't work like classes. They are abstract, but this time when I say abstract, they're 100% abstract. The interfaces are 100% abstract. So a couple of heads ups to give it. So we remember the draw method, we still made it concrete. We still made it concrete, we executed that worked perfectly fine. The abstract class is only called as abstract class, but they're not 100% abstract. It is always possible you can make that non-abstract also, making sure that there is some concrete methods. But when it comes to interfaces, we don't have any opportunity of having it. Now, where do I need interfaces? Let us understand interfaces. Okay, perfect. So there are a few quick definitions. We have to undergo this. Let's have it. This. Discuss. An interface is a special type of construct that may have some constants, and all the constants are static and final. So, very clearly, let's try knowing it. The moment you declare some variable in interfaces, they all become static and constant. Static so that you're not allowed to create an instance. Obviously, that's what I started the story with. Interfaces are 100% abstract. Since it is abstract, you cannot create an instance of it. If you have it as static, without creating an instance of it, you can still access it. And final is because once you have initialized the value in the interface, you're not allowed to change it. And do remember, interfaces are the place to define only finals. They are not there to define the variables. So some methods listed, but with no implementation, and all these methods are called as abstract. So in our classes, we have different access specifiers. We have private, public, protected, or default. In interfaces, the minimum scope and maximum scope is public only. We cannot have private. We cannot, if you say it as int x, if I say something like int x, by default, it will become public. Okay. There are a few modifiers which we can give it. Public is a modifier, abstract is a modifier, static is a modifier, or final is a modifier. We don't have to define all those things by explicitly. It is just by done itself. And interfaces cannot be instantiated. And do remember, they have nothing to do with object. In fact, interfaces are not objects. Interfaces are the behaviors what you want. For example, you are driving. Driving is a behavior. Driving is not a noun. Car is a noun. So when you want to drive, you will make use of interfaces, right? So if you are doing transaction, you're debiting money. That's a rule which you have to impose when you are doing it. So if I want to debit it, there are few rules. So those rules will be kept in the interfaces. They cannot have any Java statements except declaration. Very important. So let's go ahead. Like classes, interface is also used to define new types. Perfectly fine. So we say class name, we can say interface. A class can inherit from any interface. Okay, this is something which I want to put it in my own fashion. Okay, so now let's not go too formal here. We're going to come back to this slide a little later. A quick heads up. We know that a class extend class. So you have to understand I'm writing singular. It's a class which extends a class. There's no plural. Okay. Whereas interface extends interface or interfaces. Hope this is okay. It is possible now to have interfaces extending many interfaces. Syntactically, if I write, I'll have an interface called as um, I1, which extends I2, I3, I4, etc. This is absolutely valid and Java supports it. All right. The next one. The class does not extend an interface, rather implements interface. Okay. So all the rules which are set in the interface are followed by class. That's the whole idea. The last one. The interface neither extends nor implements the class. Very importantly. That's the first statement, second statement, third statement, fourth. Now, what is this fourth statement? Now, in fourth statement, the meaning, the interfaces are all used to define the standards. And class is somebody like now. Imagine there is the class which is called as company, which I'm sorry, there is an interface which is called as this time hours, right? You have to work for 7 hours a day. That's a rule which company has set out. So now I cannot say, hey, look at this company, since I cannot work for 7 hours, I'll work for 6.5 hours. Can you change the company rule? No. That is why I have written the interfaces have nothing to extend or implement from the class. This does not work at all. A class is somebody who has to just believe what rules has been set by interfaces. So now have a look at this. A class can inherit quickly. We'll just finish off few pointers. Then we'll go with a writing program and one real time case. Okay, a class can inherit from interface. A class inheriting from interface is a interface type. Perfectly fine. Also, a class can inherit from more than one interface. Oh, this is um, perfectly fine. So it's something like this. It's something like this. I want to write the fifth rule here. Class implements interface or interfaces. So that I've just accommodated here. Right. So here, hence interface serves as a mechanism to bind classes contractually very important word to implement methods specified in the interface. Usually project design at the very high level define interfaces to create something called as framework. So that's where the use of interfaces will come. They are nothing to do with implementation. They are more of defining standard. Interface name, class name. That's how we did it. So we have the class name extends some class, implements multiple interfaces. That's perfectly fine. So now Now I just want to have there are some examples here. If you see here, there is an interface which is called as shape, where you have area. That's what we pretty much did it with the abstract class. A similar understanding of it. Uh, let's put this. But just before this, I want to show a very important thing. What is the use of interface? Now, first and foremost, interfaces. We know that interfaces are used to show working of I used to show working of multiple inheritance. That's perfectly fine. I'm denying it. But for most of us these days, interfaces are not to show this concept. The whole idea of interfaces is to establish the contract between multiple resources. So in order to do that, let's have a look. We set a lot of contracts. To understand this, let's quickly read through this. When a large project is designed, there are many teams, with each team focusing on some aspect of the application. At some point, the application of each of these teams will have to be integrated together. Therefore, it is important that all the items have a common agreement on how they expose parts of the application so that applications can interact with each other. Thus, interfaces are created as a standard for the application and teams to work with this as baseline. That's very, very important. If you've understood this, we are good to go. Let's have a quick example of this. Imagine Imagine something like this. I'm trying to take an example of somebody like Alexa or Siri, Apple Siri, anything for that matter. So here, imagine if you are designing a remote control. So we need one remote control to start and stop many devices. So at the same time, there are like various people who are designing few applications also. So I'll say that there is a team A who are makers of remote control. The team B, makers of lamp devices. So lamp devices, they have like two shades of lamps. One is a lamp, one is a night lamp. There's another team who sits in some other corner of the world who designs what is called as AC or other devices where they manufacture. Now what they do is have a look at the scenario. They've got a problem now. Team A, who designs a remote control, they've got a method which is called as press on and press off. But team B, who are defining lamp, they got a method which is called as on and off. The night lamp extends lamp because night lamp is just a lamp. They also have on and off, perfectly fine. The team C, who's got AC, they have a method which is called a switch on and switch. Unfortunately, for some reason, they cannot collaborate because a remote control has a method which is called as press on. The press on method, when it is invoked, since we have learned from our polymorphic behavior, when I say press on, it will look for a method which is called as press on, but unfortunately, nobody has it. Nobody has it. So what I can do is there are like various possibilities. Now here is the story. Team A press on, press off which devices, where are the devices? I need a common class to represent all these devices. These devices can be passed as a parameter to press on and press off. So there's a small discussion between these teams. Let's see how it is. There's a step two. Team C, let us have an abstract class called devices. Who's your team C? Team B. Team B is called as lamp. But Team C is called as AC, but Team B says, sorry, we cannot do it because if I try using abstract class can only extend one class, they cannot have multiple class. And night lamp has already extended a class which is called as lamp. So now, can I write a class night lamp extends lamp, comma, remote control? No, that's not possible. So in that case, this is ruled out. Team B says, I cannot extend from devices because my night lamp already extends from lamp. Java does not support multiple inheritance. Okay, Team C says, okay, can we make device as an interface? So what we do is we'll get rid of the abstract class. We introduce an interface. The interface called as device. Then we'll have lamp, which implements device. I'll have AC, which implements device, and also have a look at this. There's a class which is called as night lamp, which extends lamp from here plus implements device. So this is perfectly fine. All the rules which you wanted, you can keep it in device, device, device. So let's have a look at this. Now I'll have a method which is called as remote control, which will have array of devices. They'll have two methods. One is press on and press off. For all the devices, we start iterating each of the device and try showing it. What is this device? I'm sure that in these things we should be able to map it for a simple reason. This is how we did polymorphism. So here we are doing polymorphism. It's more of a standardized way. So I said device. Which device you get? I don't know. I don't know. Until that AC or lamp or anybody implements devices, I'm good. So I just take device and call this methods. What is a method? Either it is press on, press off, on, off, whatever. I don't know. I just have to invoke it. Whatever method it could be. Now, the same story is what we have done it in polymorphism. There's nothing new. So now have a look at this. There's a design tree. There's an interface which is called as on and off. There's an interface which is called as on and off. It's got two methods. Now have a look at this. Now have a look at this very cautiously. There's a class which is called as remote control. There's an array of devices. They've got two methods. One is press on and press off. Every device when they come, any device when they come, they just pass on or off. And now I'm very clear when they try having it, the kind of methods they have to send it. Have a look at this. There's a class which implements device. What method is there in the device? The device has a method called as on and off. So you are invariably have to have on and off. You're not left out with any option. You have AC implements device. If you have switch on and switch off, they have to be invariable converted to on and off. Then class night lamp extends lamp. They will also have on and off. So what happened? We invariable made sure that everywhere we have like on and off, on and off, and off. So this way we can easily maintain the contract between multiple objects. That is how probably our Alexa, Siri, or anybody out there are working, right? So team C, I have a new device which got added user. Team A, no problem, just implement device. Team C interface saved us. It helps application to scale and it will really, really help us to extend it. So that's where the use of interfaces will come into picture. I'll be on day 5. In day 5, I'm not going to create a class first of all. I'll have an interface. Now, what is my interface called as? Which is called as device. Device. So what we do is the device will have a public void, let's say on, no simple method, and you also say void off. Now, both meaning say if you just hover it here, if you just hover on the off, you see it gives you a green signal, which meaning it is a public. So if I don't put a public in front of the method, then by default it will be public. This will be inserted by uh, somebody as a client or Java. That just puts it by Java. So now, once if this is done, I can also have some constant declare. I'll say int x is equal to 33. So this meaning this will get converted to something like this. Public static final int x is equal to 33. That is how it looks like. You write this, it gets converted to this. All right. So now I want to have somebody called as AC. AC. So we want to have AC. So this guy will implement device because we don't want to write without implementing it. We have to ensure that they are implementing. So if I just hold it, great. I have some on and off. So on the words of on and off, I just put system.out.println. I'll say I'm not putting any complicated business logic. I just want to say the AC is turned on. Great. So I just want to say the AC is turned off. Perfectly fine. So it has its own complication as how it is on and off. But anyways, we'll keep it short. So here I want to have another class, which is called as lamp, which is called as lamp. So here, this lamp will implement device, device. So I'll say lamp is turned on. I'll have the lamp is turned off. Perfectly fine. And we want to show little more in the class where I'll have night lamp. The night lamp, this time, this guy will extend lamp because they want to have some behavior of lamp and also extends and implements devices, right? So now have a look at this. Uh, I can also have, it is not mandatory because this lamp has already overridden. What I can do is I can go back to source, override actual methods. So I'll say on and off, perfectly fine. So here it is. So if not by default, it will call super, but I want to change the behavior of it. I'll say system.out.println night lamp turned on. The next one would be turned off. So let's looking back to this diagram, we will have somebody called as a remote control as in a class. We'll have array of devices. So what I do is I'll have a class which is called as remote control. I will have a method here. I'm not going to create an object here rather method because I want to have a client. So it will be a little more elaboration. Public void uh, use my device. Just on and off, whatever. I want to have um, devices, which is array of devices. Perfectly fine. I just want to say uh, for int I is equal to 0, I less than devices dot length and I plus plus. I can say devices of I dot on, right? So that's one method. Okay, let's say on device. So just to make sure on device, right? So here there's another method which I want to write it, just called as off device. Okay. So we'll not call on, we'll call off. This is perfectly fine. It is possible for you to write this for loop, or if you want to iterate each of the item, it is we have like another option. I just want to show you that. We call this as for each. For device temp in devices. This meaning for each element in devices of type device temp, I can just say temp dot off. Look at this. This method or this for loop and this for loop is pretty much same. It is exactly same. There's no difference in it. Here we use a iterator or we use a looper. Here we use a iterator by implicitly written by Java itself. Is that fair enough? So now what I want is the device client. So I want to have, I'll say something like uh, devices client. So the whole idea here is to have, I want to have device, device, which is an array of it, devices, is equal to new device of like five elements. So here I want to have devices, any devices of 0 is equal to new AC. So here I'll just put this couple of times. I want to have AC, I want to have lamp, I want to have night lamp, I want to have lamp. Look at this, it's so clear, so clear. You just push that position. Great. That's very clear. So I've got like two ACs, two lamps, and one night lamp. The whole idea here is just to invoke it. Let's see how easy it is to invoke it. And I want to have one more thing, just a quick thing. I just want to put static so that you don't have to create an object. Great. So now I will go back to device client. I will just say, all right. So here, I just say, uh, hey, I want to on all the devices, right? Whatever devices which I have it in the home. I'll say, hey, remote control, come here. Oh, sorry, what did I do? Remote, remote control dot on these devices. What are the devices? Which is there in the devices? Oh, look at this. Those guys should on all the devices. I just click on play. Oh, great. AC is turned on, lamp is turned on, AC is turned on, light lamp is turned on, lamp is turned on. All these things got turned on quickly. So I'll put a separator, remote control dot off device. Now all this thing became so quickly and easy for us. It is because we are inheriting or using the interfaces. All devices which we have turned on has been turned on. Likewise, you can even do it at individual level. But the whole idea here is to understand since we have set the benchmark of using what is called as interfaces, things are going pretty quickly. You're not investing a lot of time. If there was no interfaces, then everybody would have written their own method. But how do you map that method names? We cannot just go to remote control and say on. There will be somebody as night lamp who would have used a method called as turn it off. But I don't have a method called as turn it off. I have a method called as on and off. Since these methods are coming from devices, it becomes so easy for us to maintain the story. Now, the whole idea of having something called as interfaces is about standard. So if you ask me, hey Naveen, look at this, you tried writing something called as interface. I have an interface called as figure. So what is there in figure? You have public void area. All right. So tomorrow I'll have an interface, which is called as bank or maybe like account. In our discussion, what we had account. So this guy will have something called as public void rate of interest. I'll have public void something called as branch. Now, if you say, hey, look at this, Naveen, every time you try writing these methods, that these methods will not have any implementation. What is the use of it? Now, the whole idea here, it's not about defining a business logic in interfaces, do understand? But the idea here is to make sure we will have this interfaces so that all your parties who are overriding will follow the standard. Tomorrow, if I have a class which is called as savings savings bank account which implements account. The whole idea here is this guys, these two people who are rate of interest and banks, they have to have an implementation. They have to have. There is no escape of this. To enforce this, we will. On the verge of it, even Sun Microsystem have created so many interfaces, so many, hundreds and hundreds of interfaces. Now, let us try putting little lights on couple of them, not everything. Uh, there are like a couple of words which people use. People use JDK, J2SE, JSE. So this word called JDK and JSE and J2SE are pretty much same. So J2SE is the older name of the same product because of the licensing with Oracle Corporation. Sun Microsystem had to take it off. So that meaning Java 2. Every time there was Java 2. So Java 2 Enterprise Edition, which is J2EE. So we had Java 2 Micro Edition, Java 2 Standard Edition, and so on. So now they don't have something called as 2. It's always called as JSE. So whenever we try talking, so let's be a little cautious when you use a word. Never say it is J2SE or J2EE. No, there's nothing called J2EE now. They've all taken it off. So from the time Oracle has taken Java, so they keep everything without this too. It's only a licensing. If not, all products are same. So JSE has many classes that does a lot of common program utility methods. But for our classes to make use of those methods, we must abide by some rule or contracts. Very good. This because the utility methods need to check the callback methods defined in our classes to implement certain part of functionality. Let us take this example with something called as comparable. I just want to quickly run through one understanding. So here, imagine yourself. I have the simplest thing. I have an array of elements. I have array of elements at the positions 0, 1, 2, 3, 5, right? And I got like some elements like 7, 10, 8, uh, 355, and 32. So there are some random numbers. There's nothing special about this number. Now the whole idea here, I want to transform this to a sorted list. Sorted list. 0, 1, 2, 3, 4, 5. Right? The output should be 7, 8, 10, 32, 55, and 300. Now, this is my input, this is my output. Which is the best sorting algorithm today to sort this? Because even I don't know which is the best sorting algorithm. So next couple of weeks there might be better algorithms available and all these things. So what Java people do is, so whenever they keep updating their release, if you see, I don't know if you have tried installing JDK on your system, you would see JDK 1.8 underscore 177, 178, 171 update. So it means JDK 1.8 has 101, 170 updates. Wow, that's so amazing. Right? So what is there in the update? So what they do is they keep putting in new algorithms every time something new comes in the market. So now we don't have to understand what is the best sorting algorithm. So rather what I do is I will leave it to Java. But when I leave it to Java, there are few contracts I have to follow. This question mark, I don't know. But I know few things. Let's understand very cautiously. Any algorithm in the world. So you take bubble sort, quick sort, heap sort, try sort, Google crawling algorithm, anybody for that matter, there is something which is one defaultly stuff. What is that? Anytime I want to put the data in the sorted order, I have to compare the values between two. So I have to compare this between two values. So I may have to compare it. I may have to compare it. This concept of comparison will never go away. This concept of comparison will never go away with any algorithm. Even if you are thinking after 1 century, this will still be there. It will not go away. So on the verge of it, they have got three rules for any sorting algorithm. If the first value is greater than the second value, then the return value is 1. You just have to understand this. If the first value is lesser than the second value, this uh, comparison will return -1. If first value is equal to second value, this will return 0, right? So what I can do is my swapping of values will happen with only one of these three combinations. I might have to swap if it is greater than 0, if it is less than 0, if it is equal to 0. This is something which we have to do, right? If I want to do this, there are some contracts in the world which people have already done it. How does this contract do it? There is an interface which people have already written for this. This interface name is called as comparable. This guy, as an interface, has a method which is called as compare. what my compare will do is the compare as in a method will return a value which is called as int. Every time the value called int is written, they will check one of these three values. These values are acknowledged to Java. It is acknowledged to Java. Once it acknowledged to Java, depending on the value which is got, Java has an implicit algorithm which is whatever, even we don't know. No, all of us don't know. This question mark will be kept here. This question mark will be kept here. So these people we don't know. So on the verge of it, this algorithm is injected Java. They do a sorting according to the latest algorithm which is there, and the output is generated. The whole idea is we don't have to understand the process of how things are really working. So what we have to do is we just have to implement your class with the comparable and override this method called as compare, and we have to tell on which object I want to sort it. So on the verge of it, let's go back to this guy here to understand comparable classes in java.util. They come from a different package. Have a look at this. This time it is from util package. So let's understand this. Comparable has one method which is called a sort method. You just have to invoke the sort method with the primitive types or with the object types. It is also having few methods with this with binary search. Binary search remained constant right from 1970s because we from corporate world believe in not only the best case, we also believe in average case. But any point in time, we don't want the worst case in our time complexity. So keeping all this in mind, binary search is an algorithm which will either land up with the best case or average case. Binary search does not have the worst case at all. Right. So in this meaning, so all methods are the static like classes. In all the classes which they have defined, it's all static. Binary search requires an array to be sorted prior to making this call. So of course, in our college days, if you are recalling it, binary search, if you want to sort the values, the binary search should have the value in the sorted fashion. Who will sort? There are a few methods which we help ourselves to sort it. Let's have a look how Java will do it. It's a basic communication between two people. The first guy happens to be the student. The second guy happens to be Java itself. So now student asks, hey, look at this. That's something really cool. But I want to sort my objects too. Now, how do I sort? Just before this, I want to quickly run one simple program for all of us to understand. Look at this. Look at this. I'll go back to day 6 where we want to create a new package. A package here. Let's say com.sdet.day6. This is day 6. So I'm going to close all the classes which is opened and clear the console. So here I have day 6. Let's create a new class. I'll say sort primitive, right? So I'll say sort primitive. That's my class name. Nothing's fancy about it. So let's quickly have the main method. So I want to have an array. So primitive value, it is your choice now to have the primitive values, or it also includes the wrapper class. Somebody like string, anything is fine. So as to keep our discussion pretty simple, I use integer value. I say int numbers of array is equal to uh, uh, all right. So I can just directly put the value 45, 34, 23, 66, 77 to 50. So these are like few values which we have kept. So first and foremost, quickly, let's do for int I in nums system.out.println I want to give a separator. So here, when I click on play, have a look at this. It gives all the values in the random fashion, but I want to sort it. So if I want to sort these values, I have to find the best algorithm. Let's not do all those things. Rather, what I do is I call somebody called as arrays. Arrays is a class. I know this. This guy comes from java.util. So this guy comes from java.util dot sort. So when you see the sort, spend little time. When you're working on this, spend little time. There are so many sorts out there. There are so many sorts which can take anything. So these are overloaded methods. So I want to just pass integer value. I select the integer one, which happens to be in EMS. So sorted. So what I do is I'm going to copy the same for loop rather than typing it. I'll put it here so that we show the value before sort and we want to show the value after sort. After sort. So let's click on play. Let's click on play. Wow. Look at this. The data is sorted. Now, if you're trying hard to understand, hey, Naveen, which algorithm we tried using it, you don't have to understand. You don't have to really know what's sorted. So out of the interest, hey, we really want to know that how things are working, I would still give you the place where you can find it. So I'm sure that all of us know that it's in C drive, program files, Java, JDK. Um, you have SRC. So in SRC, you have somebody called as Java. Here you have util. You should find somebody called as array. Okay, let's sort it according to the name. Yeah, here you have arrays. So let me just copy this. I don't know if I can copy or view the file. View the file. So this is where the entire sorting algorithm is kept. So it's a huge code. You can spend some time whenever you're free to find if it is really worth having a look at this. So here it is sort. So there are like a lot of sort methods. Look at this. They have written all the sort methods, what is required. So this is where the implementation is kept. Imagine yourself. Hey, I mean, we don't have anything like primitive types, but this time we want to go little fancy, where we want to keep the objects. So what we have done with the primitive types. So now, if you ask me, oh, where is this comparable? Where is this compared to? You don't have to really understand where is this. What would happen here is something like this, something like this. This is integer of arrays or array of integers. When I say arrays.sort, they internally create an integer list once again, and this will already have something called as comparable within themselves. Just to understand better, what we do is we will try creating our own objects as to understand how things can work behind the screen. On the verge of it, let's have a look at this. Here it is. So let me go back, clear the uh, drawings which we have done. I'm just gonna delete it. Here we'll have it. So first and foremost, I'll still go with array of elements. I have array of elements. So this time I'll have four elements: 0, 1, 2, 3. I call this array of elements called as EMPS. EMPS. I'll have ID, which is 1, the name, who's Mr. A, and the salary as 100. I'll have 2, B, the salary is 3000. 3, Z, which is 750, right? So I have something like this. I make it 30. There's like 4. There's like P, and the salary would be like 2000. Imagine this is the data. But I have no concept in the world which can sort employees. Rather, if I want to sort the employee, I have to sort it based on one field. I have to sort it based on the name, or based on the salary, or based on the employee ID, or some means. We cannot say if I put everybody here, all of us in the team now, guys, let's get sorted. Now, how do you sort? Now you ask me, hey Naveen, that's right. What do we sort on? Based on the height, based on the weight, based on the qualification, based on whatever number of years of experience, name, whatever. So now the whole idea here, we have to tell Java, okay, sort based on the name, based on employee ID, based on salary, or some field which we have to mention in order to make the salary. So in order to do this, this class, obviously this EMP is an array. This will have a class. Let's assume this class name, which is called as EMP, should implement an interface which is called as comparable. Comparable. There you will have a method which is called as compare. In the compare, we have to pass this information saying that on which value we're gonna sort. We have to tell. So this is where the business logic. And this business logic, trust me, it is one line. One line. You don't have to do anything. You just have to call some. specialized method, and just do it. So let's try writing this code quickly. So this is not a primitive sort. This time this will be little object sort. Okay. So let's go back. I can use somebody called employee just to stick on to the same discussion. Employee, that's my class. We'll have this guys for private in employee ID, which is private string name. Right. This will be the name, string, private, uh, double EMP. So let's generate some uh, getters and setters. I'll say select all, say okay. So here this guy implements comparable. But just before implementing comparable, I want to show the slides. Okay. So now there's a student who asks, "Hey, can you sort my objects too? I don't want to remember the sorted algorithm. I have to spend time learning, implementing, test. Please sort my objects too." Well, the circle class also asked me the same question other day. My dilemma is, how will I know which of the fields of your class is to be compared? Let us do this. You provide me implementation for the compare, which I will call from my sorting algorithm. And how am I supposed to do that? I can pass student objects to your methods. How can I pass methods? We don't have function pointers in Java. Okay, so now that is not a problem. I will have an arrangement. There's a interface here which is called as comparable from JSE. I have a method which is called as compare to, which returns an int. If you implement comparable interface, then I can call this method to your object. It is guaranteed now if you have comparable interface implemented, then you will have comparative method. Oh, that's a good idea. I shall implement comparative method. No, you need to implement comparable interface and implement comparative. We cannot have Java does not trust us because internally Java does something called as instance of. Okay, if that is the case, things go well. It's the student says yes, boss. Let's go ahead and see how things can be done. So here I will have an interface which is called as comparable. Let me do control space. Here I'll just do double click. When I do that, it will ask me to which class type I need. I wanted from employee class. Perfectly fine. So now it starts giving me an error message. Let's see what is it. The error is all in the line 3. Let's hover on the class. Let's hover on the class and let's add this implementation. When I do this, it will give me an opportunity where I can have compared to. Okay. So now, very importantly, if I just go back to the diagram, if we just go back to this diagram here, so what happens? Imagine we have a requirement today where we want to sort based on the IDs, based on the IDs. So from here, I will try taking one. Here I'll try taking. So I want to compare first with 1 and 2. So if you want to compare 1 and 2, what Java will do is the first parameter will be referred as this because it is from this class. In this class, you will have EMP ID. Am I clear enough? You have EMP ID. What is this? Java will keep passing as a formal argument, right? In the next iteration, what happens? Maybe one remains as it is with this. I don't know. There's no promise. But the 2 will be replaced by 30. 2 will be replaced by 30. So this 30. So again, this will be formal. Or in the next iteration, I may have something else. I can have something else. The value called as this is referred to 1. I have 4, which is formal argument. So I hope this is making sense. The whole idea here is for each of the iteration here, for each of the iteration here, there is this which is referring to the current class object, then the formal argument. The same thing is happening here. If you look at this, I have to return a value which is called an int. So the return value will be 1 or minus 1 or 0, depending on the equality. On what is this? I want to do sorting based on the employee ID. For in order to do that, I'll say uh, this dot emp id, this dot emp id greater than o dot get emp id. So this value I just have to return it. This is what we just have to do it. There's nothing special I have to do it. I'm sorry, this is minus. So that it gives you it gives you the first argument. If you keep this, this will be in ascending order. All right. So the first argument, if it is a class argument, it will be in ascending order. You just have to little mugger, no other option, or you have to go ahead and try understanding algorithm. So honestly, even I have not understood. So this dot empid minus get empid. That's what we got to do. Now, if I do that, what Java will do is when I invoke arrays.sort, it will come here, check if it is implementing comparable. It will go back to this guy and check if there is a method which is called as compare to yes. Then it tries passing the employee object one by one, and it just does with swapping algorithm. It just keeps swapping. And based on this algorithm output, it arranges the value. So let's go back and check how things go well. So here I create a client sort. So here, let's have a main method. So I will have quickly employee array of emps is equal to new employee employee of this. Okay. So we can directly put the elements where the values are coming from arrays. Okay. So here, I just to want instead of setters, what I do is I'll quickly have this. Have a look at this. I'll go to source, generate constructor using fields. So I'll say okay. So there's a nice constructor which came. If not, I should have used setters. So I feel like using constructor. I'll say new employee, which is from day six package. We have to take it from day six package. That's where this guy comes from. Day six package. So I'll say 1, 2, 3. So let's quickly have of names. So I will take some random numbers. I'll have Tripti. So here I'll have salary as 5555. So now I'll just put comma and copy paste that couple of times. Copy paste that couple of times. So here I'll have, I just put some random numbers. Well, so here I'll have Kami, I'll have Krishna. So let's have Ravi, right? So they'll have different salaries. I say 5, 6, 7, 8. So here I'll have 4, 5, 6, 7. So this will be 8, 9. So whatever. So they're like some basic salaries which I have set it up perfectly fine. So now the whole idea here is to sort it. So just before sorting it, I want to show the elements. So in order to show the elements, we can use getters. If not, we still know there's somebody called as toString method, which we can override and directly show it. In order to do that, I'll go back to this guy. Here, I will go to source, override, generate toString, perfectly fine. So the checks are there. I'll say, okay, this is your toString method. So once it is done, so what we can do is quickly for employee temp in emps system.out.println temp. So let's see, these are the original values. These are the original values. 1, 2, 3, Tripti, salary. Next is Kami, Krishna, and Ravi. There are like 4 employees who are there. So now I just put system.out.println, just put after sort. All right. So now I'll say arrays dot sort. What is the array which is EMPS? So that's it. That's it. After sort, the whole idea is just to show you. Look at the way how it works. it should sort according to the names. I'm sorry, employee ID. I'm sure that it has sorted according to employee ID. And what we have done, we have not done anything. We just have told Java, look at this, we have overridden a compare to method and we are giving an algorithm. This for ascending order. So if I want to do it for descending order, the whole idea here, the whole idea here is to go back and cut this minus this dot EMP ID. So that is what you got to do it. So the whole idea is between only these two lines. These two lines are magic lines, right? So now these are like primitive values. You try playing with minus and plus. So what happens here? What happens here is something like this. So if I have this value, which is getting sorted, which is getting sorted. So what happens? The compare to method, the values are injected from the arrays. Each value comes, the first value comes, and this will be referred as this, which is in this class. Maybe next value comes as the parameter here. So now I want to do this operation, which is uh, something like this. So I want to do it something like this. In order to do this, the return value of this will be either 1, minus 1, or 0. So what Java needs is only this much. It only needs minus 1, or it needs 0, or it just needs 1. Nothing else it needs, right? So now, if we want to take it further from here, imagine if I have a string. Oh, with the integer, it makes sense. We can try using something like minus and all those things. But how about for string? But for string, you will not be allowed to have something called as um, minus or plus. So we cannot write this. So I'm going to comment of this, return this dot emp name minus this dot, sorry, o dot get emp name. Now this is wrong. This does not. But how, what should it work? So as you have compared to here, this class, which is called as string, also have this interface called comparable implemented. So let's quickly go back to this guy here in Java 8.847. So here, when I try opening the class which is called as string, they themselves have overridden a method which is called as or an interface which is called as comparable. Let's have a look at this. So here I can go to java.lang, perfectly fine. So here I have a class which is called as string. So here is a string. So this is where I wanted to show. So this class name is called a string. It has got a super class which is called as object class. Now, do you see all the implemented interfaces? It has also implemented an interface which is called as comparable. As we have implemented comparable for employee, string as a class in itself has implemented comparable. So we may have to understand little deeply here. Very importantly, imagine it. So you have to think as if you are a developer from Sun Microsystem. So you're not a developer, you're a developer from Sun Microsystem. You are allowed to, you're given in task to create a class which is called as a string class. Assuming this, you have already written a comparable interface which has it. So since string has comparable interface implemented, there is a method which is called as compare to. This has something. Don't worry, what is that? No business for us to understand. But yes, there is some business logic. Now, what we have done is we have got a class which is called as this is a class. It's a class called a string. But on the other side, we have our own class which happens to be the class which is called as employee. What this guy does is he also implements comparable. Com- So since we have comparable, it is mandatory that you should also override a method which is called as compare. So make sense? You have few variables. Int, like emp id. Very cautiously, you have somebody called as string emp name. Now, if you ask me, hey Naveen, how do I sort based on the employee name? So what I do is I will have an object which is called as O getting passed here. So one is called this object. So you will have this object, one is O object. Now we can say, okay, this dot emp name, you have to understand where is emp name coming from? Emp name is coming from string class. It means this string class is this string class. In this string class, do you have a method called as compare to? Yes. So now I can say employee dot compare to of what? Of what? Of O dot get emp. Hope this makes sense. This value is something which we have to return. So we invoke employee name compare to where is this compare to coming? Because emp name itself is from string class, this will go to the compare to class that will have the invocation of compare to here. So just put it here across. Quick look at this. I have employee name dot compare to. Where is this compare to coming from? Compare to is coming from string class. In string class, there is an interface which is called as comparable, which is implementing. I'll say o dot get employee name. Right? This is very, very, very widely used code in our corporate world. So let's go back and see if it is sorting based on the name. So it sorts with Kami, Krishna, Ravi, etc. So all these people are sorted based on the name. So if you want it in descending order, so I can have written who dot get emp name dot compare to this. Very good. So here's the story. Awesome. Look at this. All descending order. So it is as simple as this. So you have not changed anything in the client. It's only that business logic or some part of the code in the business logic is getting changed. Thank you for watching. See you in the next video.